Hey boys and girls, so today we're going over Unit 8, Lesson 4, which is modeling similar triangles. Before we get started, just make sure that your name is written down at the top and we can begin. As we look at the do now, it says, as shown in the diagram below, triangle ABC is similar to triangle DEF. AB is 2x, BC is 9, DE is 8, and EF is x. What is the length of line segment AB? All right, I already went ahead and I highlighted out that key word similar. Anytime I see similar, I should be thinking side length is in proportion. That's going to look like a fraction equaling a fraction, and we cross multiply to solve. Okay, but when I see similar, I should also be thinking not just that the sides are in proportion, but that angle measure is preserved. I'm not going to need this fact for this specific question because it's not giving me anything about the angle measure here, but it's still something that we should practice and, just reinforce. All right, so if I want to solve a question like this, the first thing I want to look at is what's going to correspond here. Well, if I look, AB is my first two letters, same thing, DE is my first two letters. This is that trick that we had gone over. If you just stack the letters, you can see what will correspond very clearly. So I know that line segment AB, which is my 2x, will correspond with line segment DE, which is my 8. So I'm going to choose a circle, all right, just to show that those segments correspond. I know that 9 corresponds with x. Those are different segments, so they're going to get a different symbol. And now I'm ready to rock. So for me, I like to look at one triangle at a time. So I'm going to use my box and my circle, okay, for my first triangle here. I like to just do top to bottom equals top to bottom. So on the top, I had a circle. On the bottom, I had a box. And that's going to equal my other triangle, which again would be 8 over x, which was a circle over a box. As long as you have some type of pattern set up, you're going to be good to go. All right, so again, this is just how I like to look at it. I do, top to bottom over top to bottom. Some other teachers I know like to do, circle to circle, big to small, and then box to box, big to small. That would have been correct as well. It's however you see it. All right. So here we go. Now I want to start cross multiplying and solving. All right, so we got, if I cross multiply 2x times x, I get 2x squared. All right, and when I multiply 9 and 8, I get 72. Now I want to get x by itself. Right now, x is hanging out with that coefficient of 2, and I got to move him out of the way. So the opposite of multiplying, which is what we just did, is dividing. So I'm going to divide both sides by 2. This cancels. Now I have x squared equals 36. Last but not least, how do I get rid of the square? By taking the square root. So I'm going to take the square root of both sides. This cancels out my exponent of 2. And now I'll be done. X will equal 6. Or am I done? I probably skipped the most important step, and I'm hoping a few of you caught me doing that. I intentionally went over this. Anytime you're reading a question, you not only want to identify what's going to be important in the question, but you want to underline the actual question itself. So that way when you're done, or really when you think you're done, because I see 6 is an answer, you're thinking it's choice 1, I don't know, let me read the question. That's what you should be doing, going back and reading the question. It says, what is the length of line segment AB? Well, line segment AB is 2x. Well, what is 2 times x? Well, we just figured out that x was 6. So what's 2 times 6? It's 12. Yeah, so the answer isn't going to be choice 1. It's actually going to be choice 2. Okay, so just be very careful with that. Anytime you are reading, you always want to underline the question before you even start the problem. All right, because little issues like that can happen. You might have thought it was 6, but it wasn't. All right, let's jump down to the guide of practice here. It says, for the pair of similar triangles below, we want to use proportions to determine the unknown lengths of the sides labeled with variables. So if I look at the first triangle, I can see I need to find this missing side. This is a variable s. And for the second triangle, I need to find this missing side. That's my variable of t. I'm going to use the same strategy that we just went over in the do now to get this done. I'm going to circle my corresponding sides, box out some more, maybe square out or triangle out, some extras. All right, so here we go. In between my 1 arc and my 2 arc is the number 8. So if I look at my second triangle, in between the 1 arc and the 2 arc is the number 6. They're in the same spot, so I know that they correspond. I'm going to show that with circles. Now I'm going to keep going. If I look at my one arc, the variable s is hanging out here, so I'm going to use a different symbol. I'm going to maybe put a box there. And again, if I look at my one arc, I can see 6 3/4 is hanging out here, so I'm going to box that as well. So this is the first proportion that I can set up, and that will get me my answer for s. Now, a lot of you might be seeing this fraction and thinking, ugh, I hate fractions. That's okay. If you type in 3 divided by 4, because we know fractions represent division, well, 3 divided by 4 is 0.75. So I could change this to 6.75 if that makes you feel better, okay? If this did not work out to a nice decimal, then unfortunately I would have to keep it as a fraction, but it did work out to a nice decimal, so I can use either one. All right, so just be aware of that. So here we go. I'm going to use a different proportion than I did in the do now. I know up in the do now I said I like to do top to bottom in one triangle equals maybe like a top to bottom in the second triangle. I'm going to just do something different. I'm going to go circle to circle and then box to box, just to show you there's always more than one way to set up a proportion, and as long as you are using some type of pattern, you will be correct. So I'm again going to use maybe a circle to circle up top. So I'm going to go big to small. I'm going to do 8 over 6 equals, then I'm going to go back and I want to do some type of like box to box. And again, if I went big to small, right, big triangle to small triangle, I have to do that again. I got to do big box, my big triangle, again to my smaller triangle, which would have been the 6.75. I actually am going to use the decimal because that looks nicer to me. And now I'm ready to rock. I'm just going to cross multiply here. Whoop. All right. 6 times s is going to be 6s. 8 times 6.75 is actually the whole number 54, believe it or not. All right. And then again, I want to get s by itself. I know that the opposite of multiplying is dividing. So I'm going to divide both sides by 6. This will cancel. And I know that s will equal 9. All right, so I just figured out that this missing variable will have the number 9 attached to it. Anytime you get an answer, it's always helpful to add it back to the diagram because it might help you later on. Now I'm just going to make a little squiggle here. And now I want to go back and I want to find that missing variable for t. All right, well, I know that t must correspond with 7 because those are the last two, all right, that are left over here. And now I want to go back and say, well, if I'm going to use 7 and t, maybe I'll use 8 and 6 as well, just because those were numbers that the question had given me. What if I made a mistake? What if s isn't 9? Okay, it is 9, guys, but you never know if you've made a mistake or not. So I always like to, again, just use the numbers from the question. All right, and then I'm going to start all over again. Again, I'll do, let's do again, maybe a circle to circle. So one more time, I'm going to go big to small. So I'm going to do 8 over 6 equals. Then I'll go back, but now I want to do triangle to triangle. All right, and then again, I want to go big to small. That would be 7 over t. And then just like we did before, my proportion is set up. Now I want to cross multiply so that I can solve. Well, 8 times t is 8t. 6 times 7 is 42. All right, and then last step, I want to get t by itself. The opposite of multiplying is dividing. So when I divide both sides by 8, this cancels. T ends up being a decimal. It's 5.25. And that's okay. Don't think just because you're getting a decimal that something went wrong, because it didn't. That's just going to be the answer for the guide to practice here. All right. You guys can flip. I'll meet you on the next page. All right. These are going to be real-world applications of similar triangles. This is something you could see in real life. As I look at example 1, it says, at a certain time of day, a 12-meter flagpole casts an 8-meter shadow. If the tree's shadow is 40 meters long, using a proportion, determine how tall the tree is. All right, if I want to use a proportion, which is important, I want to highlight that out. Anytime I see proportion, I should be thinking similar triangles. All right, so that means I should have 2 triangles. They could be the same size, but really they're supposed to be different sizes. Usually I have a small one and a big one, just like we saw on the first page. So I'm going to see if I can identify my small triangle and my big triangle based on the information that they've given me. Well, as I read the question, I can see I have a 12-meter flagpole. Here's the 12-meter flagpole. It says that it casts an 8-meter shadow. Here is the 8-meter shadow. Are you guys already seeing this? Here's the first triangle that I'm going to use in my proportion for this question. As I continue reading, it says, if the tree's shadow is 40 meters long. Boys and girls, think about when you're outside. Where is your shadow? Is it on you? Is it up on the ceiling? No, it's on the ground. So if it says that the tree is now casting a shadow, the shadow would be on the ground here. So if the tree's shadow is 40 meters long, it's this distance at the bottom that's going to be 40 meters long. I'm going to highlight that out in a different color. Okay, it says using a proportion, here's the question, we want to determine how tall the tree is. Well, here's the tree. If I want to see how tall it is, that's really asking for the height. I know that heights are perpendicular with the ground. Okay, so just be aware of that. So if I'm looking for how tall it is, I can see they already have a variable h here. I'm just going to go over it with my pen. All right, they had a variable h. This is the length that I'm looking for. So again, pink, pink, pink. Here's the bigger triangle that I was trying to find. All right, well now I'm ready to rock. The only issue now is that if I'm using a proportion on similar triangles, those triangles should really be right triangles. Well, that's okay. What do I know about trees with the ground? They're perpendicular. Typically, they're straight up and down. So I know this will be a right triangle for my big pink guy. And the same thing, if a flagpole is being, kind of cemented into the ground, it's usually not on a slant. It's usually, again, perpendicular with the ground. And this is what makes these questions so challenging because they're real life questions. All right, so again, here I go. I got my two triangles. If you want to redraw them, I suggest you do that if it's going to help. I'm actually going to redraw them myself. So I have this bigger pink triangle. I have an H up top, I have a 40 at the bottom, and I know it's a right triangle. And then in my smaller triangle, I know that the height is 12, I know that the base is 8, and I also know that this is a right triangle as well. And now I'm ready to rock. I'm going to set up my proportion. Here we go. So I have the height on the left, right, for both triangles, the bigger and the smaller. And then I have the base for, again, the bigger and the smaller. And now I'm going to set up my proportion. I'm going to do, just to switch it up again, I'm going to do top to bottom equals top to bottom, just because that helps me not make any mistakes. So I'm going to do H over 40 equals 12 over 8. All right, and that's perfectly legal. We are good to go. So I'm going to cross multiply to get this question done. So here we go. If I cross multiply, H and 8, cross multiply 40 and 12. Well, 8 times H is going to be 8H. 40 times 12 is actually going to be 480. All right, I want to get H by itself so that I can answer my question. What's the opposite of multiplying? You got it, dividing. So when I divide both sides by 8, it turns out that H is, 60. All right, so to determine how tall the tree is, the tree is going to be 60 meters tall. All right, and we are good to go. Let's look at example 2. All right, example 2. Miss Picciano places her 5-foot camera tripod approximately 300 feet from the center of the base of the Washington Monument. Lying on the ground, she visually aligns the top of her tripod with the top of the monument and marks her location on the ground approximately 2 feet from the center of her tripod. Use Ms. Picciano's measurements to approximate the height of the Washington Monument. Wow, there's a lot going on here, but that's okay. We're going to break this down. So before we go anywhere with this question, I don't know how many of you might know what a camera tripod is. So I pulled one up on my phone here. I'm just going to put it under the camera so you guys can see. That's what a camera tripod looks like. Tri means 3. So it has 3 legs, if you can see that, and then the camera just sits on top, all right? Pull this back to the side. So if it says Miss Picciano is placing her 5-foot camera tripod approximately 300 feet from the center of the base, of the Washington Monument. Well, there's two numbers here. One's humongous, 300 feet, and the other is super tiny, it's 5. Now, I'm hoping the takeaway that you just got from seeing what a camera tripod looks like is that the tripod itself is perpendicular with the ground. It stands straight up and down with the ground, okay? So when I'm looking for that 5-foot camera tripod, I'm looking for a height that's going to be pretty tiny, and it's got to be perpendicular with the ground, okay? So I'm thinking this is the segment that's going to be the 5 feet for the camera tripod. So I'm going to put a 5 here, and now I'm done with the 5 for the question. It says that the camera tripod is 300 feet, so here's the tripod, and it's going to be 300 feet from the center of the Washington Monument. Well, here's the Washington Monument, okay, and here's the center of the Washington Monument. So I know that from my tripod to the center of the base, to the center of the bottom here of the monument, this is going to be a length of 300 feet. All right, so now I used my 300 and I'm done. Lying on the ground, she visually aligns the top of her tripod, okay, with the top of the monument. So here I am. I'm lying on the ground. I'm so happy. Here's my hair, right? And I'm seeing the top of the tripod being aligned with the top of the monument. That's how I know this is where I should be laying. All right, if you guys are in class for this lesson, you're going to see me laying on the ground. So here I go. All right, I'm laying on the ground, and I want to mark my location on the ground. The ground is down here. I want to mark my location as 2 feet from the center of my tripod. Well, here's the center of my tripod. Here's where I'm looking. So I know that it's got to be this little distance right here that's going to be 2. So I'm going to fill that in. So now I use the 2 from the question. Use Miss Picciano's measurements to approximate the height of the Washington Monument. Well, here's the monument. I want to know the height, which really means I want to know how tall it's going to be. So I'm going to use the variable h to represent the height here. And now I'm ready to rock. So just like all of the other questions, this is a real life word problem. So I have to really read into it to see what it's asking me so I know what I have to do to solve. Just like the other questions, I should have a smaller triangle and a bigger triangle. So here's the little baby triangle at the bottom. And here's the mama triangle all the way surrounding it. Here I go. All right. So I have those 2 triangles. Now I can only set up a proportion if I'm dealing with right triangles. All right. I know that the tripod is perpendicular to the ground, so I know this is going to be 90. I'm going to add a box. And I would hope that buildings are perpendicular with the ground, because if they were like leaning to the side, that would be very unsafe, and I wouldn't want to be in that building, okay? So it's definitely going to be a right angle as well. So now on the side, just to set myself up here, I'm going to redraw both triangles. So I'm going to have the mama triangle here, and I'm going to have the little baby triangle here. Okay, in the mama, I have h for the height, so I'm going to add that on. Now be very careful for the base. A lot of you are right now thinking, oh, it's 300. Really? I don't think this forms a triangle if I stopped right here. That forms some type of 4-sided shape. Don't forget about the little 2, guys. All right, so the base is 302. All right, so 302. Then I'm going to go back for my tiny little yellow baby triangle. I got 5 and 2, so I'm going to fill those in, 5 and 2. Now I'm ready to rock. Here I go. I'm going to do the height on the mama with the height on the baby, and I'm going to do the base on the mama with the base on the baby. All right, I got to find those corresponding sides so I can set up my proportion and solve. Now I'm ready to rock. I'm going to do top to bottom in the mom, then I'm going to do top to bottom in the baby. So I'm going to do h over 302 equals 5 over 2. And then just like before, we're going to cross multiply to solve here. All right, h times 2 is 2h. 302 times 5 is 1,510. Last but not least, I want to get h by itself. I have to get rid of that 2, so the opposite of multiplying is dividing. So I'm going to divide both sides by 2. So h, my height, is going to be 755. So when the question says, I want to approximate the height of the Washington Monument, I'm going to say the height of the Washington Monument. Let me fill it in like this. The height of the Washington Monument is 755 feet, because that's the units we were using in this question. It was feet. All right, and now I'm completely done with example 2. Meet you on the next page for example 3. All right, example 3, it says, in the diagram below, line segment AD intersects with line segment BC at C. I can see that here's AD, here's BC. They are definitely crossing at C. Line segment AB is parallel to line segment DE. That's important. I want to stop right there and actually highlight that out. All right. How do I mark if two lines are parallel? I do that little arrow. So if it's line segment AB that's parallel with line segment DE, I want to put arrows to show that. All right, here again, I know that this is the parallel line symbol. And what do parallel lines form? Yeah, they form alternate interior angles. I know I'm shorthanding this, but it's just to remind myself that that's what I should be looking for at some point in this question, I'm assuming. Okay, if D, oh dear, that should say if CD, oh my goodness, if CD is going to be 6.6, so I want to fill that in. Here's CD, it's 6.6. And if DE is 3.4, here's DE, this is going to be 3.4. And if E, oh my gosh, it should have been CE. If CE is 4.2, oh, and BC, oh my goodness, there's a lot of segments, and BC is 5.25, right? Using a proportion, we want to determine the length of AC to the nearest hundredth of a centimeter. So I'm going to go back, and I always want to underline my question. So it says using a proportion, I have to determine the length of AC, and I'm going to do that by rounding to the nearest hundredth. Don't forget that. All right. Anytime I see the keyword proportion, I should be thinking similar triangles. I want to set up a fraction equaling another fraction. Now, when I'm first looking at these two triangles, at this point in time, I have no idea what's going to correspond. I don't know if 5.25 corresponds with 6.6. Does it correspond with the 4.2? I don't know. So here we go. Add this as a little star. The first thing you need to do is identify, add this to your notes, identify the rigid motion, okay, so that you can see what will correspond. All right. And in order for me to decide what the rigid motion is going to be, that's where the parallel line symbol comes into play. I know that parallel lines form alternate interior angles. How do I find those angles? By highlighting out the letter Z. So that's what I'm going to do. I'm going to start on my parallel line. I'm going to make my way over so that way I can end on my parallel line. So now I know yellow to yellow and yellow to yellow. Those are my alternate interior angles. I actually want to go over those with a blue pen here just so you can clearly see it. Now I'm ready to start, because what rigid motion is going to map ABC onto DEF? Is it going to be a reflection or is it going to be a rotation? Well, if it's a reflection, that's just like flipping a page. So B should flip right over and map onto D, but is that true? No. B should be going to E. So when you move on a diagonal like this, it's a rotation. So now I know 5.25 does not correspond with 6.6. That would be a reflection, which I don't have. I have a rotation. So 5.25 corresponds with 4.2, all right? And 6.6 would correspond with whatever AC is going to be. Now the question says determine the length of AC. If I don't know what something is, what do you call it? Yeah, we're just going to call it X. So I'm going to put an X here for right now, and I can set up the proportion. okay? I like to, again, use one triangle at a time. So I'm going to do circle over box. So I'm going to actually write that here, circle over box, because I don't want to confuse myself, because this is a rotation. You could easily make a mistake. So if I do circle over box, it's going to be 5.25 over x equals, now I got to go to the other triangle. Again, I want to do circle over box. That's going to be 4.2 over 6.6. Okay, again, that was my circle over my box. Now that I have set up my proportion, I'm ready to rock. Here I go. I want to cross multiply to solve this baby. All right. 4.2 times x is 4.2x. 5.25 times 6.6 is 34.65. And then last but not least, I want to get x by itself. What's the opposite of multiplying? You got it. Dividing. So I'm going to divide both sides by 4.2. This will cancel out. And now I know that x equals 8.25. But be very careful. The question says I want to determine the length of AC. Does x represent AC? Yes, it does. Did I round to the nearest hundredth? Well, let me see. 100 has 2 zeros, so I should round 2 places after the decimal. And I did. 8.25, that is rounded to the nearest hundredth, so I'm good to go. So just to finish this question, I want to write down that it's line segment AC that's going to be 8.25 centimeters long, because I want to round to the nearest hundredth of a centimeter. All right, and then if I want to be over the top, I can go back. I'm just going to highlight out my final answer here just so it's very clear. All right, but that should have been your answer to example 3. I want you guys to now try example 4 on your own. This is very similar to questions we have already worked on today. Okay, it's definitely a little challenging. Be very careful. Okay, so at least try to get it started, and if you feel like you're, a little stumped, definitely unpause the video and start checking back to see kind of what I'm doing. But I really want you to try one on your own, and I want it to be example 4. All right, so at this point, press pause, give it a try, and check back when you're done. All right, here's example 4. So it says a flagpole casts a shadow 16.6 meters long. Well, if this is the flagpole, I know it's this entire distance that will be 16.6 meters long, because we know that shadows are always on the ground. Tim stands at a distance of 12.45 meters from the base of the flagpole. Base is a key word. I should be thinking bottom. So Tim is 12.45 meters from the bottom of the flagpole. So I know it's just this little chunk here, this distance, that's 12.45. Again, and it's saying such that the end of Tim's shadow meets the end of the flagpole's shadow. All right, so here's his shadow. It meets the end of the flagpole shadow. And I can see they both meet right over here. If Tim is 1.65 meters tall, so that's his height, 1.65, determine and state the height of the flagpole to the nearest tenth of a meter. So here's the question. I have to determine and state the height of the flagpole to the nearest tenth. Be very careful with that, okay? All right, so here we go. If I want to know the height of the flagpole, well, here's the flagpole. I put an H on there to represent height. And now I just have to find my 2 similar triangles so I can solve this question. I want you guys to add that on right over here. I want you to put a little star, and I want you to write, find the 2 similar triangles, because that's the goal of this entire lesson. Whenever you see a real life question like this, all right, so if I look at the smaller triangle, which I highlighted out in yellow, right now I only know the height. I don't know the base. So how did I get the 4.15? Well, I took 16.6, the whole segment, and subtracted it away from what I knew, which was 12.45, so I was left with what I didn't know, the 4.15. All right, so now I have the height and the base of the little guy, and I already had the height and the base of the bigger one. I set up a proportion, I cross-multiplied. If I round to the nearest tenth, 10 has 1 0, so I should be 1 place after the decimal, so I am good to go. All right, and that should have been example 4. If you guys flip over the independent practice, the homework is on the back here. Please make sure you are showing all of your work, because if you are not, okay, it's not going to be full credit. If you need help, you can always message us on Canvas, but that was it for this lesson. Have a great day.